China's biggest train manufacturer has announced it will build a 600 km/h maglev rail train. While the CRRC Corporation says the first prototype will be ready.
Just when the world thought airplanes were the peak of fast travel, China has unveiled a machine that could rewrite the future of transportation. It's not science fiction, it's real, it's built, and it's faster than a commercial jet. This revolutionary train promises to blur the line between ground and air travel, changing how we move forever. The question is no longer if trains can outrun planes, it's when the rest of the world will catch up. Buckle up for something wild and lightning fast. The groundbreaking reveal. On a humid morning in Qingdao, the world's eyes turned to China as engineers rolled back the curtain on a machine that stunned even the most forward-thinking transportation experts. The new train, known as the CRRC Maglev 620, is not just another addition to China's already massive high-speed rail empire. This is a technological leap that redefines how fast can be. Capable of reaching a jaw-dropping 620 km/h.
It's a maglev train with a top speed of 600 km/h.
This train isn't just breaking speed records, it's threatening to dethrone commercial airplanes for short and mid-range travel altogether. For reference, a Boeing 737 cruises at about 828 km/h, meaning China's latest train now competes with the skies while running on solid ground. During recent tests, the prototype reached its maximum speed on a specially constructed magnetic levitation track, setting a new milestone for ground-based travel. At the core of this marvel lies superconducting magnetic levitation, a technology that allows the train to hover above its track, eliminating friction entirely. With no wheels, no grinding, and no rail resistance, the train glides on a cushion of magnetic force, making the ride not only lightning fast, but also whisper quiet and unnervingly smooth. But the spectacle doesn't end with speed. The CRRC Maglev 620 boasts futuristic engineering from end to end. Its aerodynamic shell is designed like a jet fuselage, complete with a nose optimized for air slicing and a body crafted from lightweight carbon fiber composites. Inside, the train feels more like a luxury aircraft than a traditional rail car, with reclining seats, real-time digital displays, and intelligent climate systems. China's state-owned CRRC, China Railway Rolling Stock Corporation, and top universities collaborated for over 5 years on the train's development. The goal, not just national pride, but a genuine transformation of mobility. First deployment will likely connect major city pairs, such as Shanghai to Hangzhou or Guangzhou to Shenzhen, potentially reducing a 2-hour journey to just 30 minutes. Eventually, authorities envision expanding these lines to link megacities across the country in a web of ultra-fast, ground-based travel. So how exactly does this technology work? How can something that floats move faster than most aircraft, all while consuming less energy and producing near zero emissions? The science behind the speed. At first glance, the idea of a train floating above its tracks and traveling faster than a jet seems like science fiction. But in reality, the science behind magnetic levitation, commonly known as maglev, is well established and now entering a new era of application.
But when China kicked off its research on superconductive maglev in the 1980s, there was a giant leap in the industry.
China's CRRC Maglev 620 is built on this very principle, pushing the boundaries of physics and transportation by replacing wheels with magnetic force. Maglev trains do not rely on mechanical contact to move. Instead of rolling along steel rails, they levitate above a guideway using powerful magnetic fields. This allows them to glide forward without friction, one of the biggest limitations in conventional rail systems. By removing the resistance between wheels and rails, the maglev achieves smoother rides, less wear, and, most importantly, much higher speeds. The core technology powering this advancement lies in superconducting magnets. These magnets are capable of carrying massive electrical currents without losing energy, creating intense magnetic fields that both lift and propel the train. Once the train levitates, linear motors embedded in the track push and pull it forward using shifting magnetic fields. Essentially, the guideway becomes a magnetic conveyor belt, moving the train in a controlled, incredibly efficient manner. The train literally floats at a height of around 10 millimeters above the track, and this lift happens even when the train is stationary. What's even more impressive is how precise and quiet the system is. There are no moving parts rubbing together, which means little noise, minimal vibration, and drastically reduced mechanical wear. Passengers experience a ride that is not only fast, but also smooth and virtually silent. Compared to both traditional trains and airplanes, maglev systems are far more energy efficient over short to mid-range distances, especially when factoring in takeoff fuel costs and delays common in air travel. Safety is another highlight of maglev technology. Despite the extreme speeds, maglev trains operate on highly regulated, computer-controlled systems. Thousands of sensors continuously monitor the train's position, speed, and magnetic balance, making real-time adjustments as needed. These trains are less vulnerable to weather, unaffected by turbulence, and operate with astonishing reliability. If any anomaly is detected, automated emergency systems engage immediately, providing an added layer of passenger security. While the technology sounds futuristic, China is proving it can be implemented at scale. The engineering behind the guideways, the magnetic systems, and the control algorithms has been perfected over years of research and development. Engineering marvel. Building a train capable of reaching 620 kilometers per hour is not just a matter of adding power and removing wheels. It requires a complete rethinking of how a vehicle interacts with its environment. The CRRC maglev SICO-20 is a result of years of cross-disciplinary engineering, combining advances in aerodynamics, material science, and precision control systems to produce a machine that can defy conventional limitations. But just as impressive as the train itself is the infrastructure that makes such speeds possible and safe. Every curve, contour, and component of the CRRC maglev is designed for aerodynamic efficiency. At these speeds, air resistance becomes a major obstacle, similar to the forces faced by jet aircraft. To counter this, the train's nose is sleek and elongated, shaped to minimize drag and reduce the shockwaves created when entering tunnels, phenomena that can destabilize high-speed trains. The body is constructed using ultra-lightweight materials such as carbon fiber reinforced composites and aerospace-grade aluminum alloys, which reduce overall mass without compromising strength.
Unique materials that can completely repel magnetic fields and therefore float above the magnetic track.
These materials also help the train handle the extreme forces of acceleration and deceleration without structural fatigue. The track system, known as the guideway, is perhaps the most overlooked but vital part of maglev operation. Unlike traditional railway tracks, maglev guideways are constructed with extreme precision. Even the slightest deviation or bump at high speeds can lead to serious instability. To account for this, the guideway must maintain tolerances down to the millimeter. Special concrete structures embedded with magnetic coils are laid in continuous stretches, often elevated to avoid disruptions from ground-level obstacles and to reduce land usage. These guideways also house the linear motor components responsible for propelling and braking the train with exact timing. To support the train's floating mechanism, powerful cryogenic systems keep the superconducting magnets at extremely low temperatures, often below 200 degrees C.
A class of materials was discovered to achieve superconductivity at negative 196 degrees Celsius.
These cooling systems are built directly into the train's chassis, requiring advanced insulation techniques to maintain performance without affecting passenger comfort. Engineers also had to design redundant power and cooling systems to ensure continuous operation in case of failure. Equally important is the integration of real-time monitoring and control systems. Thousands of sensors line both the train and guideway, constantly measuring magnetic alignment, speed, vibration, and environmental conditions. Data from these sensors is processed in milliseconds by onboard AI-driven software that adjusts magnetic forces and train behavior on the fly. This level of precision allows the train to maintain balance, speed, and direction at all times, even during rapid acceleration or emergency braking. Can such a sophisticated system be rolled out nationwide or even globally? And what impact would it have on everyday travel inside China? Impact on domestic travel in China. China's vast size and population have long posed major transportation challenges. With sprawling megacities, dense urban corridors, and remote inland regions, efficient travel has become both a necessity and a national priority. The CRRC Maglev 620 enters this landscape not just as a technological achievement, but as a potential game changer for how over 1 billion people move across the country. It promises to do for domestic travel what the high-speed rail revolution began 2 decades ago, only faster, more efficiently, and more sustainably. Consider the route between Shanghai and Hangzhou, 2 economic powerhouses separated by roughly 175 kilometers. By conventional high-speed rail, the trip takes about an hour. With the new Maglev, it could drop to under 20 minutes. Beijing to Guangzhou, over 200 kilometers apart, could become a 3-hour journey, rivaling air travel in both time and convenience, especially when accounting for airport check-ins, delays, and baggage procedures. For millions of commuters and business travelers, this kind of time saving
Responsible for more high-speed rail tracks than the rest of the world put together.
is more than a luxury. It's transformative, but speed is only part of the equation. The Maglev system is also set to integrate seamlessly with China's existing transportation network. New stations are already being planned alongside current rail and metro hubs, allowing for fast, easy transfers between systems. For passengers, this means hopping from a local subway to an ultra-fast Maglev with minimal friction. For cities, it offers an opportunity to become regional hubs in a new web of high-speed connectivity. Economically, the implications are enormous. Cities that were once peripheral or considered too far for daily commuting may now see a boom in development. Talent and labor can move more freely, businesses can expand their footprint, and tourism could skyrocket in less explored provinces. Real estate markets may also shift, as once remote areas become viable locations for living and working due to shortened travel times. Much like the arrival of high-speed rail in smaller cities boosted their GDP and infrastructure investment, the Maglev promises a similar ripple effect, but on a potentially larger and faster scale. From an environmental standpoint, the new Maglev lines could also help reduce China's reliance on short-haul flights, which are some of the most carbon-intensive forms of transportation. With no direct emissions and lower energy consumption per passenger kilometer, Maglev trains represent a cleaner alternative. If adopted widely, they could contribute to China's broader climate goals, including its pledge to peak carbon emissions before 2030 and achieve carbon neutrality by 2060. Yet, while the technology is ready, one critical question remains. Will the public embrace it? How much will tickets cost? Will it be a premium service for the elite, or a widely accessible option for all? Public perception, pricing models, and long-term policy decisions will ultimately decide the Maglev's reach within China, but the groundwork is being laid for something unprecedented. But what happens when we look beyond China's borders? Could this innovation reshape how the world travels? Global implications, redefining long-distance travel. While China leads the charge with the CRRC Maglev 620, the global implications of this development extend far beyond its national borders. This isn't just a story of one country's technological triumph, it's a wake-up call to the rest of the world. For decades, air travel has dominated long-distance journeys, often viewed as the most efficient option for connecting cities and nations. But with Maglev trains now approaching, and in some cases rivaling commercial flight speeds, the equation is beginning to shift. If adopted and expanded internationally, this technology could fundamentally transform how humanity moves across continents. One of the most striking advantages Maglev has over traditional air travel is its efficiency and convenience. Airplanes require airports, long check-in times, strict security procedures, and significant fuel consumption just to get off the ground. In contrast, maglev trains can depart from city centres, offer quick boarding, and maintain consistent speed without turbulence, noise, or emissions. For distances of up to 1,500 kilometers, where much of the world's air traffic occurs, maglev systems could offer faster total travel time door-to-door, especially when airport congestion is factored in. Environmentally, the stakes are even higher. The aviation industry is responsible for roughly 2 to 3% of global CO2 emissions and is one of the hardest sectors to decarbonize. Maglev trains, especially when powered by renewable electricity, offer a low-emissions alternative with the potential to drastically cut down on the need for short and mid-haul flights. Countries focused on climate goals and green infrastructure, especially in Europe, may begin to look seriously at maglev as a key part of their transition strategy. Already, interest is brewing beyond China. Nations like Japan, Germany, and South Korea have experimented with maglev technology, though on a smaller scale. Japan's SC maglev, which has reached speeds of 603 km per hour in tests.
On a test track west of Tokyo, Japan's superconducting maglev train hit 603 km an hour.
Is expected to connect Tokyo and Nagoya in under 40 minutes once completed. However, China's ability to industrialize, mass produce and deploy such systems quickly gives it a considerable edge. If China starts exporting this technology, we could see a wave of infrastructure deals with developing nations looking for modern, high-speed solutions that leapfrog older technologies. There's also the very real possibility of international corridors emerging, trains that connect countries or even regions. Imagine stepping onto a maglev in Berlin and arriving in Paris in under 2 hours, or traveling from Kuala Lumpur to Bangkok in the time it currently takes to check in for a flight. The political, economic, and logistical challenges are significant, but so are the opportunities. Still, high costs and complex infrastructure requirements remain barriers for many countries. Laying maglev tracks demands precise engineering, extensive land use agreements, and long-term funding commitments. Yet, as global competition heats up and pressure mounts to reduce emissions, nations may soon have no choice but to consider such bold investments. So, where does this leave the world? Are we at the dawn of a new global transportation age, or will the technology be held back by politics, cost, and inertia? Race for supremacy, China versus the world. As China races ahead with its groundbreaking maglev technology, a quiet yet powerful competition is unfolding across the globe. The battle isn't just about building the fastest train, it's about establishing leadership in the next generation of transportation. The country that masters ultra-high-speed ground travel may not only transform domestic mobility, but also control a key pillar of the future global economy. In this emerging race for supremacy, China has taken a decisive lead, but the competition is catching up fast. China's advantage lies in its ability to scale. With decades of experience building the world's largest high-speed rail network, the country has already proven it can execute massive infrastructure projects at unprecedented speed and efficiency. When China unveiled its first maglev line in Shanghai back in 2004, it was seen as more of a novelty. But today, with the CRRC maglev 620, it's clear that China no longer sees maglev as an experiment. It sees it as the future. The government's long-term transportation plans include a vast network of ultra-high-speed maglev lines connecting key economic regions, reducing travel times, boosting productivity, and strengthening national unity. However, China isn't the only player on the board. Japan has been developing its SC maglev system for decades, with plans to link Tokyo and Osaka at speeds exceeding 600 km per hour. What sets Japan's model apart is its use of electrodynamic suspension and tunnel-based routes, which make it ideal for mountainous terrain. Though technologically impressive, the project has been slowed by cost overruns, environmental concerns, and political hurdles. Germany, the original pioneer of maglev technology through its Transrapid system, now finds itself largely outpaced, with no major domestic maglev lines in operation despite its early lead. Meanwhile, in the United States, much of the conversation around futuristic travel has centered on Elon Musk's Hyperloop concept, a vacuum tube-based transportation system designed for even higher speeds. While the idea has captured imaginations and headlines, it remains in the prototype phase, with no full-scale commercial deployment in sight. The key difference between Hyperloop and maglev is that China's solution is real, tested, and operational. It's not theory, it's steel, magnets, and motion. The global geopolitical implications of this transportation race are just as important as the technological ones. If China begins exporting maglev infrastructure to countries involved in the Belt and Road Initiative, it could gain long-term influence over the economic lifelines of dozens of nations.
China's high-speed rail system, known as Gaotie, is the object of envy for many countries.
Fast, affordable, and Chinese-built transportation networks might become standard in Southeast Asia, Africa, and Eastern Europe. This would give China not only economic leverage, but also a dominant position in setting the standards for 21st century transit. But how will the world respond? Will other nations double down on their own technologies to compete, or will they align with China's vision and adopt its models? Public response and future prospects. Excitement runs high among many, especially business travelers and urban commuters eager to cut down travel times drastically. The idea of slipping between cities in under an hour, comfortably and quietly, sparks imaginations and raises hopes for more convenient, connected lives. However, some skepticism remains, questions about ticket prices, accessibility, and whether the technology will truly be affordable for the average citizen. Affordability and accessibility will be decisive factors. If the maglev remains a premium service, accessible only to wealthier travelers, its impact will be limited. But if pricing strategies align with mass transit ideals, it could become a daily lifeline for millions, reshaping where people live and work. Governments will need to balance cost recovery with public benefit, a challenge that requires smart policy and investment. Beyond cost, trust in new technology is vital. Maglev's safety and reliability must be proven not just in tests, but through consistent, everyday use. Early, successful deployments will be crucial to winning public confidence, as will clear communication about environmental benefits and overall impact on quality of life. The maglev's success could trigger broader societal changes. Ultra-fast travel might dissolve traditional geographic boundaries, making regional economies more interconnected. People could live farther from city centers without sacrificing convenience, easing urban congestion, and possibly even revitalizing rural areas. Yet, challenges remain. Infrastructure costs, land use debates, and integrating maglev with existing transport systems require careful planning. How governments, industries, and citizens navigate these challenges will define the trajectory of this new era. China's maglev is more than a train. It's a symbol of a future where speed, sustainability, and innovation converge.
As this very train was designed to hit a speed of 620 kilometers per hour.
The world watches closely, waiting to see if this extraordinary leap in travel will indeed change everything, forever. To discover similarly interesting videos, subscribe to the channel and get notified for new uploads.